Hey everybody, welcome to Math with Ace. Ace here, helping you work on statistics today. We are focusing on confidence intervals with two proportions or two means. So we're focusing on a difference in the two. Now remember, we use a confidence interval to estimate a value. What if we wanted to know whether there was a difference in the proportion of people who are in favor of a proposition in, let's say, Napa County versus Solano County? Or if we wanted to know the difference in average age of TikTok users in Napa County versus Solano County. So those are some things that we can do with confidence intervals where we're trying to figure out a value that we're going to estimate. When we're doing confidence intervals, we have a four-step process that we go through where we state what we're going to do, we plan by checking conditions, we do the math, and then we make a conclusion. And our state, plan, do, conclude four-step process for confidence intervals remains the same. We want to perform, or we want to create a 90% interval for whatever we're talking about in context, where our parameters are either proportions or means with p or mu. So it depends on what type of problem we're dealing with. So you want to ask yourself, first of all, do I have means or do I have proportions? And if so, what process am I going to follow? So we have the same statement. We want to create some sort of interval, whatever the confidence level may be, for, and then whatever our parameter difference symbols are, the true population something difference, or actually, you know what we could say, the true population difference. No, I like it before. The exact wording you could put where you want the difference to be, but what the percentage is your confidence level. So this is typically like 90% confident, 95% confident, 96%, 98%, 99%. Those are some standard confidence interval levels. And then the next one is your parameter difference. Now, if we're talking about proportions, you know that that's going to be a p parameter symbol where we have p1 minus p2. For means, you know, we use mu. So we have mu1 minus mu2 and difference subtraction sign. And then the next one is the parameter word, mean or proportion, in context. So the true population proportion difference in TikTok users in Napa versus Solano. So P1 minus P2 is proportions. Mu1 minus mu2 is means. When we're checking conditions, we check conditions the same way that we check conditions for one sample. The only difference is we do it for both groups that we're talking about. So both of these need to be random. Means and proportions need to be random, and it is both groups need to be randomly sampled or assigned. Very important that you're talking about too. Independent, same thing. Both groups need to be less than 10% of the overall population. So N1 needs to be less than 10% of the population 1, and N2 needs to be less than 10% of the population 2. So both groups that you're talking about, you need to compare to 10. And then normal, same thing. Both groups need to meet the conditions that you're talking about. Now remember, for a mean, means could be normal by the population is given to be normal. Or the sample size is at least 30. by the central limit theorem, or you have to graph, and the graph shows no strong signs of skewness or outliers. So graphs, symmetric, no strong skewness or outliers. That's true for both. So this is both samples. So N1 population either needs to be given to be normal or is at least 30, or you graph it. N2 population is normal or it's greater than 30, greater than or equal to symmetric. For proportions, you have to check both. N1 p hat 1 is at least 10, and N1 1 minus p hat 1 is at least 10. So the successes and failures for the first group are at least 10, and the successes and failures for the second group are at least 10 as well. It's not just one, they both need to be true. Actually, in this case, there's 4 things that need to be true. And if those conditions are met, we're safe to proceed and we can perform calculations. If your sample is not random, you cannot generalize to the population and it's a waste of your time. If your sample is not independent, you run the risk of sampling the same people twice and you're getting bad data. If your sample is not normal, you cannot use normal probabilities for calculations. So now we run into what does it look like for us to calculate a confidence interval? This is the do portion. Now remember, for proportions, you have a 1 sample Z interval. Now it's a 2 sample Z interval, where you had 2 sample Z interval. And for means, you have a 2 sample T interval. And remember, we're using T because we do not know the population standard deviation. If you know the population standard deviation, you should not be estimating the value because you needed the value to calculate standard deviation, so that doesn't really work. And what the intervals look like, remember it was point estimate plus or minus the margin of error, or we had the point estimate was p hat or x bar. Now we have the difference in p hats, and the standard error needs to be accounted for in our groups. And so what this looks like for our point estimate for proportions is instead of P1 minus P2, we're using the sample proportions. So we have P hat 1 minus P hat 2. That's the point estimate, plus or minus the margin of error, which is the critical value, which I denote with the asterisk and alpha over 2 because it's your confidence level, and the alpha over 2, same process that we followed before. But then instead of the square root of P hat 1 or P hat 1 minus P hat over N, we need both of them now. And we're doing both of those under the square root. So we have P hat 1, 1 minus P hat 1, all over N1 plus P hat 2, 1 minus P hat 2, all over N2. And that is because we have 2 different groups. We're not adding the variation separately, and we cannot subtract away variation. So even though it's a difference, you don't get closer together when you have more things. Your variability does not subtract, become 0. You don't get less spread out together when you're combining the 2 things. So that is your proportion. I'm going to draw a little purple line here. That is the formula for your interval. For a T interval, instead of P hats, we're dealing with X bar. So we have X bar 1 minus X bar 2, plus or minus a T critical value at alpha over 2. But in this case, before we had standard deviation divided by the square root of N. Now, we need to be able to add together the variability like you do in the proportions. So we're doing our standard deviation of the first sample divided by the sample size of that group, and the standard deviation of the second sample divided by the sample size of that sample. But remember, we have the square root of N. We're actually going to combine the whole thing under the square root of N, as we did with proportions. But in order to not have variance, we need to, in order to account for the standard deviation, we need to square it and then square root it to get back to standard deviation. So this is your 2-sample T interval. If you were to do this in Staplet, this is categorical, this is numerical, or quantitative. And you're either entering the data for your interval, or you're entering the mean and the standard deviations of the samples for each of these. So you're dealing with multiple groups in this situation. So see the text that I've given you on the Staplet instructions. And then we are making our conclusion that is exactly the same. So we are 90% confident that the interval captures the true population mean difference of whatever it is. So again, this is your confidence level. This is your lower bound, your upper bound. This is your either P1 minus P2 or mu1 minus mu2. And this is proportion or mean. And this is your context. Some schools do it differently, or your teacher might tell you to do something differently. I love this 4-step process. Learned it from a long time ago with my practice of statistics textbook, and I just think it's the best method. Remember that we're confident that the interval captures the true difference, not the true differences between this range. You either got it or you didn't. Your population value doesn't change. And so you're not giving that range. You're saying, here's my interval. We either capture it or we didn't. All right, stand by for a couple of videos explaining the 4-step process with actual examples. Thanks for watching.